Sorry for the inconvenience. Internet of this connection was disconnected. So what we are talking about? We are talking about this blockchain under DIL for the healthcare applications. So already we have discussed about the blockchain-based DL and what are the advantages of this. We have seen a few of the advantages, that is elevated data security, automation, cumulative judgments, as in case of swarm robots, enhanced robustness. Data is analyzed without any fault. So if we look into the healthcare systems, basically the healthcare systems uses different models or different ways the healthcare systems are helping the patients for diagnosis as well as prediction of the disease, suggestion of drugs, etc. So some of the systems that are used in case of healthcare are AI system, system. Basically, this natural language processing is a subset of AI that interprets text as well as languages as humans do, such that it can be represented in the form of a computer, or it can be stored in the form of a computer that AI can able to look into the text, look into the data or the reports, etc., to suggest some drugs or suggest some medications, etc. So computer vision based methods, basically the computers interpret and comprehend the visual environment. So when we are talking about the visual environment in case of healthcare systems, it will comprise of some images, images, MRI images, fundus images, and these images are basically utilized for analyzing the different conditions of the disease as well as the stages of disease and medications. So blockchain-based DL-based systems are also used. So yesterday we have discussed about the parameters, that is data types, what are used in case of healthcare sectors, and mainly they are classified into three categories. If you look into the data types, they are consist of image data, which comprises of X-ray, CT, computed tomography, magnetic resonance imaging, ultrasound images, videos, etc. So these images have been used to identify some abnormalities present in different organs or different tissues, etc., or different abnormalities that is found in the bone or other part of our body. So text data, if we look into the text data, already we have discussed that this comprises of clinical reports, lab reports, handwritten notes, prescriptions, other documents, etc. Audio data, in this case, that is basically a time series data. A one-dimensional data is nothing but the audio data. Here already we have discussed about the coughing, breathing, heart sounds, other sounds, etc. Except this, there are some signals that is known as the biomedical signals are also used for analyzing the health condition of the patient, and these biomedical signals are mainly comprised of ECG, electrocardiogram, EEG, electroencephalogram, EMG, electromyogram, that is known as the muscle signals, etc. So this diagram I have shown yesterday, and this diagram I have taken from this Professor Poddar paper, that is AI-based healthcare system using blockchain technology, a state-of-the-art systematic literature review, as well as future research directions. And they have mentioned this artificial intelligence healthcare, how this artificial intelligence is used for healthcare sectors for analyzing the different databases such as text, image, as audio. And also we have discussed that once this data, first the data are acquired, that means they are captured, then some cleaning process, or we can say that some pre-processing steps have been followed to do some filtering or do some separation of high quality data from the low quality data, or in medical sector they are termed as medically suitable data as well as medically unsuitable data. That means the data which are of high quality consist of more diagnostic features or diagnostic informations, and these data have been gone through the feature engineering. Basically, this feature engineering is some image processing process or signal processing process by means of which certain features, uniqueness about the diagnostic information is captured, and these diagnostic informations are basically helpful for modeling a particular kind of a model, whether it is a deep learning model or a machine learning model, etc. So these features plays a very vital role in all the kind of data like text, image, as well as audio, and the features have been used for the purpose of classifications. So in case of text, image, as well as audio, these features have been extracted, that is passed into some DL algorithms, and these DL algorithms will perform the work of classifications. So if you look into the task that is performed in case of text data, that is the extraction of important facts from the text. That means maybe some patient history, or maybe some suggestions provided by the doctors, or some other kind of information related to the medical conditions, or related to the medications, etc. So this classification of information as well as opinion mining is done here. In case of images, the task that is performed, that is object detection, object classification, object localization, object analysis. This represent to one of the best examples. Suppose we'll take the case of a cancer, then whether cancer is present in the skin or cancer is not present in the skin. If cancer is present, then which type of cancer it is present? If this cancer which type is there, then what is the stages of the cancer, which stage the patient is now present. If this is the stage, then what will be the next suggestions, that is what is the medication to be given, or what are the suggestions to be given to the patient, or to be the affected person or affected people. And what will be the next steps that to be followed in terms of insurance, or in terms of some government rules that to be followed. So if you look into the audio data, in the audio data are basically one-dimensional data. Under this category of this ECG, EEG, EMG, all are coming. So this basically used for sound detection, sound classification, audio spectrum analysis. If you consider the case of ECG, that is electrocardiogram, electromyogram, EEG, electroencephalogram, then we can look to the different conditions of these different organs. Suppose we'll take the case of ECG. This is related to the condition of the heart, as well as heart functionalities. If we'll talk about EEG, this is represent to the different state of our brain, the different waves that is generated due to the different activities that we are performing in day-to-day life. So that means if I am sleeping or I'm feeling sleepy, then this EEG signal is basically get changed. Basically, in EEG signals, doctors or healthcare people are looking to alpha, beta, gamma, delta waveforms. So next is coming to this application point of view. If we look into the text, to analyze a vast clinical data, convert into a clinical data to computer manageable format. Basically NLP, that is natural language processing, is performing this task. When this text data is converted to a computer manageable format, they can be easily used by an AI system or a decision making system, such that the patient can get the suggestions about the medications as well as the medicines. We can able to identify the critical conditions of the patient. We can able to identify the diseases. If we look into the image data, they can be used for many purposes depending upon the which part of the body or the which organ is get or the image is taken from the which part of the organ. So this can be used for different applications like radiology, cardiology, dermatology, fundoscopy, lab test, as well as patient monitoring, etc. Similarly, this audio also automatic diagnosis of respiratory pulmonary diseases. In case of ECG for heart, EEG in case of EEG, that is corresponding to the brain as well as the activity of persons. So if you look into the challenges that is present in case of these databases that is present in or generated in case of healthcare systems, basically the text data are of different format. Different doctors, or we can say healthcare specialists, write in different languages. They have a unique format format for representing the information. So they have a different way of representation. If you look into the different healthcare sectors, they have also different way of representing the lab reports. There is no uniformity present. Whenever we are talking about the different health sectors, privacy violation, security breaches are also present. Sometimes when we are talking about the classification or detection, basically there is a lack of trust present in the AI models, and one AI model can able to separate or classify the cases more correctly for one kind of images, then it cannot classify the same thing for the other kind of images. One of the best example that we have already done, so we have developed some pre-trained network of deep learning in which we have performed the classification of skin cancers and classification accuracy. But when we have used the same model for the tumor detection in case of MRI data, the accuracy is very, very high, and it is more than 90%. So it is a very it is not trustworthy, or we can say that there is a lack of trust present in the model. Secure resource of sharing is required. Privacy preserved knowledge sharing within a research. In the research and as clinical experts. So this is the blockchain process. Already Professor Vidyasagar that initiate transactions, block created transactions, block broadcasted within the network, miner server, then result broadcasted within the miners, consensus completed, miner add block to the chain, modified chain replicated at each node as transaction completed. So now, if you look into the evolution of a blockchain in healthcare, this is healthcare to 4.5. So this healthcare 4.0 basically represent a global healthcare within a real-time monitoring. That means how we can able to analyze the real-time healthcare of a particular person. It involves basically data analytics as well as AI. In 2016, blockchain was suggested for this healthcare. And if you look into the advantages, there's has a numerous of advantages like electronic transfer, exchange of healthcare records. In 2016, Ajira Itala developed this MEDREC framework based on blockchain to manage the electronic medical records. Media Bichen, that is developed by Omar Italian, sorry, this is 2017, not 2027, privacy preserved data management for healthcare systems. In 2018, blockchain is get integrated with AI as well as IoT, that Internet of Things for healthcare. Why the IoT plays a very vital role in case of healthcare systems? Basically, nowadays, I mean, say after 2018, people are acquainted with different type of wearable devices. These wearable devices can able to capture different healthcare information about a person or a subject or a patient. So what are these wearable devices basically capturing? The wearable devices are capturing temperatures about body, the blood pressure, ECG signal, heart rate, as well as sometimes the emotions of a person also. These wearable devices are continuously collecting the data and they are sending into the server for analysis purposes. So if we'll look into a healthcare center or healthcare or a particular healthcare system, then there are many patients are using these wearable devices, and these wearable devices are continuously streaming the data either to a fog unit or we can say to a server where this analysis is occurring. So IoT and AI now comes together for decision making, and the blockchain is used for the security purposes or for secure of data sharing. So in 2018, this blockchain is integrated with AI as well as IoT for the healthcare industry or healthcare sector, and it has advantages of more efficient management of electronic health records. So due to this blockchain with AI and IoT, it has a more efficient electronic health record management, remote patient monitoring, because the patient are using a wearable devices, and the wearable devices are continuously streaming the information about the patient either to a mobile device or to a fog unit, such that it will be directly going up through a Wi-Fi network, or by the help of a 5G, or by the help of a mobile network. It can communicate it to a centralized server for the analysis purposes. If there is some abnormalities occurring, then this central server gives an indication to the patient, to either to a mobile phone by the help of a message by the mobile phone, or it will indicate this information to the healthcare expert or healthcare parties or healthcare experts or doctors. So this is autonomous diagnosis is available due to the integration of blockchain with AI as well as IoT, and this is a distributed parallel computing come into picture. In 2019, telemedicine with blockchain is used for healthcare, and this secure remote delivery of healthcare services are possible due to this telemedicine with blockchain in healthcare. So blockchain-based fog monitoring framework is used to recognize the human activity or to identify the human activity. So remote patient monitoring with big data is possible due to this blockchain as well as fog monitoring framework. Basically, what is this fog? We'll talk about later about more detail of this fog unit. So this fog unit is continuously collecting the information or the patient health information from the sensors which are used on the at the patient, that will be continuously monitoring. In 2020, this blockchain for federal learning with 5G as well as beyond started. So what is this federated learning? This federated learning is nothing but a subset of machine learning approach. And in this case, the training occurs across several decentralized edge devices or servers, keeping local data samples without being exchanged. What exactly it is representing? Suppose we are present in a healthcare system and I have wearable devices. This wearable devices is collecting the data from these patients, and this data to be analyzed or analyzed by the help of a local server without being exchanged. So training occurs across several decentralized edge devices or servers, keeping local data samples without being exchanged. So but there is a protection as we are using this federal learning or federated learning. So due to this federated learning, this protection as well as privacy are very important during the collection, management as well as distribution of electronic health record data. Because in this case, the data is kept at the server or the local server without being exchanged. This is analyzed by the help of federated learning. So this is one of the blockchain-based federated learning system. So here there are large number of devices, that is device 1, device 2, device 3 as well as device 4 to collect the data, as well as they are using the different local models. So this red color here, this is a local model, stores some local parameters. This gray color, this is also a local model which stores about the local parameters. This green color, this which is associated with device 3, some sensors. This is also a local model. This rhombus, that means I can say this blue color symbol, that is also a local model. So this is a global unified model. In case of federated learning, the training or analysis of the data is present at the server or the edge server without sharing this information or sharing of this data. In 2021, Healthcare 5.0 is coming into picture, which uses intelligent telesurgery technology with 6G enabled tactile internet. If we look into the ITU standard, this tactile internet has a low latency in combination with high availability, reliability, as well as security. So whenever we are talking about the telesurgery, it with a continuous video, or we can say continuously video streaming, and the robot is doing the surgery by the supervision of an expert, which may be present at some distance locations. So this technology, that is a tactile internet, due to low latency as well as 6G or 5G beyond, as well as beyond, which gives rise to the advantages of high availability of data, reliability of these communication systems, as well as the security of these communication systems. So in this case, the Internet of Medical Things environment is coming into pictures. So in last slides, we have discussed about the Internet of Things. So in Internet of Things, we are basically looking into the sensor data, and that is passed into the fog devices. And either this fog devices is taking some decision based on some weights developed by the DI network, or it is going to the server to taking some decisions. But Internet of Medical Things look into the images, the videos, and it can able to do the intelligent telesurgery due to the development of communication technology, that is 5G or beyond. So DL with blockchain assisted secured image transmission and diagnostic model plays a very vital role here. So this is a diagram here. I have shown how this evolution is occurring in case of our healthcare systems. And this is the whole idea I have taken from the one of the paper of Professor Vidyasagar. So here in 2016, this blockchain came into picture. And 2017 also blockchain is used. So in 2016, this trusted data marketplace, secure medical data access, secure sharing of personal health records, monitor of supply chain of drugs is occurring. And 2017, the blockchain has been used in case of healthcare system for privacy, preserving healthcare data management system, electronic health record management system, as well as increase interoperability in case of our healthcare systems. In 2018, blockchain, artificial intelligence, as well as IoT together is used for these healthcare systems. The blockchain, AI, that is artificial intelligence, and IoT is used. So there is a huge advantages or huge benefits that is occurring for these healthcare systems, like blockchain AI framework for electronic health record management, as well as automatic diagnosis, distributed parallel computing architecture for precision medicine, structural health monitoring, that is transparent information sharing, autonomous diagnostic, secure analysis, as well as management occurs. In 2019, blockchain, AI, IoT, fog computing, big data have been used in case of healthcare systems. This will help or provides the advantages of using telemedicine, intrusion detection in case of IoT-based healthcare system. This uses a decentralized server for exchange of data, image data processing, human activity detections. So due to the involvement of AI, IoT, fog devices, the patient activity becomes more clear, or patient activity can be analyzed more efficiently. In 2020, blockchain, IoT, federal learning, explainable AI, 5G, as well as 6G coming into picture. Due to the involvement, due to the development in the communication system, that is 5G and 6G, the latency reduces. Due to the latency reduces, this will give additional benefit to our healthcare systems. And this provides artificial intelligence as well as multi-agent based distributed ledger system for better privacy, security of the electronic healthcare records. Blockchain for privacy preserved occurs in case of 2020. Privacy preserving federated learning in electronic healthcare occurs because federated learning performs the work of analysis at the server or the fog devices without exchanging of the data. And this is occurs due to the more number of IoT devices or wearable devices are used in case of healthcare sectors. So healthcare framework to combat COVID-19 like pandemics is possible in this 2020 due to the development of 5G, 6G, IoT, blockchain, as well as federated learning. In 2021, the blockchain, Internet of Medical Things, bio-inspired computing, etc. coming into picture, which tells about the telesurgery, as well as blockchain technology as a solution for cyber attacks in case of healthcare systems. So here I have taken some review of the blockchains in healthcare. So here I have summarized some of these articles which tells about the specific type of blockchain platform they have used, and blockchains used in case of the healthcare system. So Hussein et al. 2019, Karjar et al. Adhosin et al. In 2019, Farooq et al. 2020, Nirkami et al. 2020, as well as C Itala 2020, Tondon Itala 2020, Houghton Itala 2020, Sohak Itala 2021, Hussein Itala 2021, Omar Itala 2021, Ahmad Itala 2021. They have used the blockchain into the healthcare for, or they have blockchain into the healthcare. They have shown that how blockchain is used in case of healthcare sectors. So this is the diagram that I have taken from one of the paper of Professor Udara, is published in 2020, which tells about the different blockchains, or the different blockchains that has been used in healthcare sectors. And if we look into here, this black is representing public blockchain. This blue color is representing the private blockchains. Am I audible? So yeah, so this is the figure which represent the blockchain for AI in healthcare, which tells out the different type of blockchains Okay. So in pages of AI model, we have used this data layer, that is classification algorithm, as well as a model layer. So as we are talking about this medical data is acquired by this data acquisition systems. Once the data is get acquired, this will be separated into high quality as well as low quality data. We are basically preparing a model, and after this data is get acquired, we are feeding this data into a classification network. This classification network is consist of a classifier or a training model. So basically we have to model this AI, or that is a deep learning, by making or by taking the characteristic into account such that the training error will be get low, as well as the testing error also get very low. So once the model is get trained, then we have to deploy the model, and this model has been used for any specific kind of application, either a classification of diseases or classification of tumors or any kind of disease progression, etc. So these are the things, this is the pages that is AI model have been used, and this diagram I have taken from this Professor Vidyasagar's paper. So when we are talking about this model as well as the medical data or healthcare data, so as healthcare data is mainly consist of three types. That is image data, text data, as well as some reports, or we can say some records. Along with that, some signals are present like EEG or ECG, and we are using this data for by help of a deep learning model for doing the classification or doing the analysis, etc. So when this data is get analyzed, basically this is affected by different type of attacks. So this attack can be present either the data place, or that occurs during the classification stage, or that will also possible at the models. So this attack can be classified into different categories. This attack, that is the input stage, if there is some attack, that is invasion attack or poisoning attack. So this is done by the help of spoofing, physical attack, or adversarial attack. Attacks at the classifier or the network itself, that is nothing but a poison attack, or that is called your the Trojan or backdoor attack. We'll just discuss these things. In case of a model, there may be some adversarial effect is occurring, that is called poisoning attack, that is time slide channel attack. So these are the few of the attacks that is affecting the performance of this decision making in case of the healthcare systems. So what are these attacks? If we look into these attacks, that the data is a small change in input leads to an abnormal behavior of the model is known as the attack. So if we look into the envision attack, when a network is fed an adversarial example, we are carefully attributed input that looks and feels exactly the same. So poisoning attack make the inputs accepted into the training data and thereby affecting its ability to produce accurate predictions. So spoofing, physical attack, adversarial attacks, that is changes in image that cannot be detected by the eye. Trojan attack, that is known as the backdoor attack, that is poison the input sample to make the network modify itself to work correctly. It is different from the adversarial attack. The network is not modified. So if we look into the difference, that in Trojan attack, the input sample make the network to modify itself to work correctly. But it is in case of adversarial attack, the network is this is different from this adversarial attack, and the network is not modified in case of adversarial attack. So in Trojan attack, the network is get modified. So both Trojan and adversarial attack take place in case of the pages. So here one example has been shown for this Trojan attack. Here I have, so that means this figure also I have taken from this Professor Vidyasagar's paper. So here this fundus image have been shown. This is the fundus with some abnormalities. Basically fundus image representing the images of the retina, which consist of the blood vessels, optic disc, macula, fovea, etc., etc. So this is one malignant input image. So this is a benign input sample. So this is a benign input sample with a trigger. So that means there is a Trojan node is present, so that this model is get affected. So this is called the Trojan attack. That means a small changes or adverse changes occurs into this image. So model next this attack that is occur to the model, that is called the time slide channel attack. What is this time-side channel attack? Basically, the depth of the network is responsible for execution, because if the depth of this AI network or DL network is very high, it is taking more time for execution. So this is vulnerable to time-side channel attack. So depending upon the time required for gathering the output, an adversary can conclude about the depth of the layer. So if you know what is the time is required from the input to the getting the output, then you can able to decide that how many number of layers or basically, or what is the depth of this network, you can able to predict it, or the adverse can able to detect it. So adversary uses a regressor for a different time with the same depth, and this information is used to mimic the model with a similar functionality to the original model. So here there are some attacks that have been presented. Here, in case of natural language processing, the clinical decision support system is used for unstructured data for decision. So the attacks in case of NLP, that is a natural language processing, that is called the adversarial attack, that is text, visual similarity, maybe there is a swapping of the characters, there may be a typographical error, there is a semantic similarity, that is paraphrasing or synonym. So here is a computer vision healthcare system, so which there is a attack is present. So here there is a normal image with a hairline fracture is present. So if we'll use some attributions into this X-ray images, there is an adversarial image is get generated. So they have the hairline crack is not visible. So the computer vision is used for image classification, object detection, object tracking, etc. So now AI in acoustics. When we are talking about the acoustic, it is nothing but a one-dimensional signal. And here are the speech signals, the coughing signals, the crying signals, maybe ECG signal, EEG signals also come in this category, because this is also one-dimensional signals. So when there is a attribution is attacking to this normal acoustic signals, then the cough cannot be easily detected. The changes that is occurring, we cannot able to. Similarly, in case of ECG, EEG, also the attribution leads to the misdetection or the misclassification of the abnormalities that is present in the heart, or the different waves that is generated from this brain or different parts of the brain. So if we look into this different type of attacks, in case of NLP, computer vision, or acoustics, so this nature of data that we are using, in case of NLP, that is discrete in nature. In case of computer vision, that is called the pixels. In case of acoustic, this is nothing but a time series data. So if we look into the DNA architecture, here we are, in case of NLP, people are using convolution or recurrent neural network. Computer visions, people are using convolutions, acoustic, recurrent neural network. Complexity attack, that is of the attack in case of NLP, is very, very moderate. In computer vision, it is easy to attack. In acoustic, it is difficult. Perceivability by human, in case of NLP, this is easy. In case of computer vision, this is difficult, and acoustic, this is moderate. So this is the data set building with blockchain in NLP-based healthcare system. Already yesterday, Professor Vidyasagar has given some of his research work and shown how this blockchain has been implemented for their project. So here, the figure shows that the data set building with blockchain, this natural language processing based healthcare system, in this case, hospital A, diagnostic laboratory, hospital C, hospital B, as well as research centers are communicating the data with each other. The data may be of in different formats that we have already discussed. And this is signature of this data, which is taken by the help of a smart contract. And this agreemented participation of the database in the building is there. And they can able to communicate with these different organizations. So this is the blockchain network. Here, this blockchain solution for protecting the training page of this natural language processing, which takes about the different nodes of collecting the data, and the local gradient, which performs the work of word embedding, and the consciousness algorithm is present, which works on this global model as well as distributed ledger. So it consists of the protect NLP classifier as well as the algorithm as well as protect NLP model. Similarly, in case of the training phase, that is called the post-training phase. This occurs in case of training phases. And in case of post-training phases, that is called the testing phases, we have to give some unknown text into the network, which is passed into the word embedding, then it is passed into the distributed ledger, so where there is minor pool is occurs, and the conscious based on majority, we can able to tell what is the text is basically meant for. So database creation for the computer vision based healthcare systems. Basically, in computer vision systems, this medical image data is created. So this is also taken from this different images. Request for medical image to be put. Then there is a chain code is there. So upload the medical image to IPFS. Then return the hash for the images. Then this stores the hash in case of a blockchain. Then after, if some research center is requesting for the access of the medical image of databases, then they authenticate users and provide the hash to the images to the research center, and access to the medical images check and images with the hash. So this is the way how this database is get created for the computer vision in case of healthcare systems. And this diagram represent how blockchain to protect the training phase of a computer vision. So this is the IPFS chain code. This is the medical image. This computer vision learning process and computer vision model is present. So this total model is consist of protected computer vision classifier algorithm as well as protected computer vision model. So this is at the case of testing phases, how blockchain has been used for the testing of a particular image. Suppose an unknown image is given to this, this initiate the access to the model. So distributed ledger is there and learned feature vector is generated. Once the feature vector is generated, this looks into the distributed ledger, but to provide a comprehensive diagnosis with some explanations. So similarly, this creation for the acoustic based healthcare system where the sensors are placed into the account to get the databases. So this is the similar kind of this previous work. So here it is similar to that of the NP also. So this is all about this data creation as well as how blockchain has been used in case of medical or healthcare sectors. So if we look into the challenges in the healthcare systems, so lack of computational environment, much heat, huge electricity of consumption, lack of computers, patient data are handwritten, internet access is inconsistent and not very good in a country like India. Expensive systems should be shared by government, healthcare, as well as pharma industry, insurance company, etc. So if we look into the challenges in healthcare in terms of lack of IT system, like a country like India, so interoperability is the problem due to several digital solutions. Own models as well as setup, different healthcare sectors have different models, different setups. The setup don't have setup has or are not uniform. So patient when switching over from one healthcare center to another healthcare center due to some or other reasons, the patient has to go for again the test as well as the treatment. So it basically increases the overall expenses. So before coming to this conclusion, just I want to show you the fog unit, how exactly this fog unit basically representing. So this is a fog unit which consists of different sensors, and these different sensors are passing this information to either a fog unit. Here the fog unit is nothing but a mobile devices, and this mobile devices takes the data and send the data to a fog bus broker, and this fog bus broker is sent the data to a cloud system as well as to a deep neural network model, where this deep neural network model will generate the weights for finding the or performing the classification of this. So I'm not going through this, it's time is over, so I'll just going to the conclusions. So what we have discussed today, so the blockchain and IoT with DL for this health systems. So this has numerous of advantages that we have already discussed. We have discussed about the challenges in healthcare, and also we have discussed how this blockchain has been used in healthcare for improving the performance of the healthcare systems. So if you have any questions, you please write in the chat box. Now it's the time. Vidyasagar sir is waiting for the presentations. It's already 10:30. So thank you all. Can I stop screen sharing? Yeah. So if you have any questions, please ask in the chat box, or so that I can able to answer all your questions or all the queries. So we'll take a break for 2 to 3 minutes and let Professor Vidyasagar join, and then we can start our next session. Good morning, sir. Am I audible? Yeah, yes, sir. Yeah. Sir, we can start the session. Just now I have completed, 10:30 I have completed.
Okay, I will start then. Let me share my screen.
Yes, sir. Sir, your
Okay.
screen is visible. Yeah, fine, sir.
Visible? Okay, all right,
Yes.
cool. Let's start. So, okay, so today is the last session, last lecture on blockchain. And today I'm going to cover blockchain as a service for interoperability. So I will be talking about the challenges or adoption challenges faced with blockchain technology. And after that, I will show you how some of these challenges can be resolved using a blockchain platform that we have built here. And it will also give you an idea of how how you can work with different blockchains using the platform that we have built. Not only that, you will also get an opportunity to see a demo of the system live in action, where you will be able to see how I can create a transaction and post it on Polygon blockchain. Okay, so let's get started. So let me start off with mentioning some of the challenges. I mean, yesterday we did speak about blockchain technology, but however, getting the technology adoption within organizations is a challenge. So there are a number of challenges that blockchain kind of suffers when it comes to widespread adoption. So first, I will talk about these different challenges so you get an idea of these issues. And then we will see how we can address those. Just give me 1 second. Okay, sorry about this. Let's start. So what is the first blockchain challenge regarding adoption? So one of the biggest challenge in adopting a new technology is whether there are existing skilled people or programmers or developers who can build this technology. So that is one of the biggest challenge because blockchain is still an emerging technology. And because it is an emerging technology, there are a lot of new things that developers have to learn. And as more and more blockchain platforms come in the market, the amount of people with the required skills is not growing at the same pace. So having the right skills to build a blockchain is a challenge, and which is one of the reasons why we also see the adoption difficult, because even if companies do want to implement a blockchain solution within their organization, when they look to hire people, they may or may not find the right talent in a reasonable budget that they have to achieve their blockchain project ideas. So lack of skilled people is one very major problem that the industry is facing. And the thing that what is being done to resolve this problem is to educate educate developers who are already familiar with some basics, right? So getting them or upskilling them to a new blockchain platform is much faster. And hence you will see a lot of training institutes or universities have started programs in blockchain to fill this gap where we are not finding the right talent to drive the blockchain based projects. The next challenge is the perception of high risk in adoption by senior management. And this typically happens for, I guess, any new technology before it becomes mainstream, right? So there has always been a challenge with any new technology where companies are a bit hesitant to adopt a new technology because not everyone is using it. So they are a bit cautious on whether this is the right technology to use and whether they should go ahead or not. So I'll give you an analogy here so that you get an idea of how companies think and how that thinking changes over time when the technology kind of becomes more popular. In this case, I want to give you the example of cloud computing. Okay, so most of you, I guess all of you know what a cloud is. Cloud computing is where the servers are located not in your organization, but they're located in the in companies like Amazon or Microsoft or like Amazon Web Services or Microsoft Azure and so on. So when this concept of cloud computing first came to the market, cloud also experienced the same challenge, right? The adopting of the cloud technology was a different way of thinking for a lot of organizations, because during those days, companies were, the way they used to manage their IT infrastructure was they would have all the servers in the organization itself. They used to manage it in-house, and they used to think that that was the most secure way to manage your data or manage your infrastructure. And this continued on for quite some time. And later, as slowly companies started to move towards cloud and cloud became mainstream. And now if a company was using their own IT infrastructure within an organization, and especially if that company is not an IT company, if it was any like manufacturing or production or some other kind of a company, people started questioning, why are you managing your IT infrastructure in-house? I mean, that is not your core competency. Your main job, your main core value is to build whatever product. Maybe it is a car that you're building, or maybe it is a phone that you're manufacturing. So it is not ideal to have your IT infrastructure locally. So you should have it on the cloud. And it went to such an extent that earlier people used to think having the in-house IT infrastructure was more secure, to a stage where when people started to think that if you have your IT infrastructure in-house, it is not secure, because the cloud providers provide much more security, much more benefits, right? So that shift in the perception of how technology adoption happens is a good example with this analogy, where cloud was first considered something that nobody wanted to use, and now it has become mainstream. So similarly with blockchain as well, I feel that we are going through the same level of or a same life cycle, where blockchain is new now. People are thinking that, oh, maybe it is not the right time to invest in technology. We are still very happy with using traditional databases or other technologies that help us manage our data, to a stage, maybe in 5 years or 10 years from now, we don't know. But it would become a fact like, oh, why don't you have it on blockchain? Why are you still using a traditional database? So that shift, that change in the perception will happen over time. And at this stage, the technology is considered quite risky for a number of reasons, and I will discuss them shortly. But that perception among senior management will change, but it will take some time. The third challenge, which I find, is lack of understanding. And this is on both the sides of the fence. So it is companies who are thinking of blockchain or to use blockchain technology, but they fully don't understand what's going on with the technology. And the second bit is the excuse me. And the second bit is the like I already mentioned, the lack of skilled people. So on both sides, there is a lack of understanding on because the technology is progressing so fast and in a rapid manner. It is difficult for a lot of companies as well as developers to catch up at the same pace. So that always that mismatch in the marketplace. Next thing that I have actually personally experienced when I did these 12 projects that I had discussed yesterday, or in the that I discussed in the earlier sessions, was that companies in fact find it very cumbersome or difficult to understand how a blockchain platform actually works. What are the key elements that go into the blockchain? Why is it designed this way? So there are a lot of questions and a lot of complicated interface to actually access a blockchain, right? So first of all, you need to have a digital wallet. You have to have a private key and a public key. A lot of people, a lot of companies that I spoke to, or the people that I dealt with there, they were still not very comfortable managing a public-private key. They were happy to have a they were happy to just use a username and password, and they used to ask me, what happens if I do use this digital wallet, and if I, for some reason, I forgot my password, forgot my private key or public key, is there a way that I can receive like a reset password? Is there a reset private key option? But it is not, and because that is not considered to be secure, and conveying that information, conveying that concept that no, you cannot in fact reset your private key or use a forget private key option to enable that. It just doesn't, they just don't get an understanding of why this would not be possible. But that is the case. So complicated user interface is also one challenging problem with blockchain adoption. Next is capital investment. Yesterday, I briefly spoke about the investment that is required yesterday, I briefly spoke about the investment that is required to build a simple blockchain use case all the way to an enterprise-grade blockchain solution. So whenever we are talking about large amounts of investments, companies are a bit concerned as whether they are going to get the return on their investment or not. And this is the challenge with any new technology. Whenever a new technology comes to the market, one of the major hurdles for its adoption is tangible or a visible ROI or return on investment. If companies are able to see that by investing X amount of dollars in a new technology, they are going to get 2x, 3x, or 10x returns, then they will be more comfortable making that investment. But that has been one of the challenges with blockchain, that the initial upfront capital investment. And a lot of this also goes to the incorrect information that is spread all around the internet. So the numbers are not correct. People just read some news article or a blog article which kind of inflates the number too much or doesn't put it in the right context. And then people are, and then the actual users feel that, oh, that's a lot of investment to bring in a solution like this. So capital investment is also a major hurdle in adoption. Next is blockchain development process. So I will not talk a lot about this because I already covered it yesterday in the last session. But briefly, when we did projects with all our clients, we took this three-phase approach. Phase one was use case evaluation. Phase two was developing a proof of concept. And phase three was scaling the blockchain solution for a production to make it production ready, which means it was ready for actual customers or users to start using it. Typically, the use case evaluation or phase one is where we first discuss with the client and try to understand what problem they are trying to solve and whether blockchain is going to be the ideal solution for them to get those results. Yeah. So use case evaluation is an important step because we at this stage we do an assessment of whether blockchain will be able to solve the challenges that the company is trying to face. And if if our assessment is that no, they cannot, I mean, they will not get the expected benefits by implementing a blockchain solution, then we clearly and upfront tell them that that I think blockchain is not a suitable solution for what you want to achieve, and you can explore other technologies for that. So we do that, and like I said, we have conducted such discussions with over 100 clients, and from those 100 clients, we worked on 12 projects. So we actually screened a lot other clients as well, but those projects eventually did not go ahead for various reasons. But those that went ahead were, we also went through that exercise with them. So once the use case evaluation was done, the second bit was to develop a proof of concept. And a proof of concept is a step where we kind of work in a 6 to 8 week period to come up with a simple blockchain solution that kind of shows the capacity or the capability of how blockchain can help address one specific use case that the client is trying to assess or to build. So that 6 to 8 weeks is a very tight timeline, but given our experience, we are able to deliver it in that time frame. And that kind of gives the client a sense of comfort that, yeah, I think this is what we want. And if it can be done in 6 to 8 weeks to get an initial proof of concept, then they're happy to go ahead and invest the next bit to develop a minimum viable product. So that is phase 3, which is scaling the blockchain solution, which is taking the proof of concept and making it production ready or ready for commercialization, where users or customers, we can onboard users or customers on the platform, and it will be used within the company's business, day-to-day business. In terms of the development cost, I discussed this earlier. So a minimum complexity application would cost anywhere around $100,000 or a bit more than that. dApps with average level of complexity would cost around $200,000, and enterprise blockchain solutions could be $400,000 and more. Yeah, so these numbers are very reasonable numbers because, like I said earlier, we do part of the work. We do part of the work in Australia, and we outsource other bit of our work so that we are able to still offer a blockchain solution in a reasonable with reasonable funds, with reasonable capital investment. But the question now is, are companies willing to invest so much capital? Even though we have tried to bring that benchmark or the levels fairly low, but that may still be not affordable to a large number of companies. So this cost of technology has always been a barrier to blockchain adoption, or not just blockchain, for any adoption, where any new technology adoption, where the technology is still proving itself. It is not proven like any other well-established technologies. So what my vision for blockchain is that if you imagine, say, 20 years ago, 25 years ago, when email was first introduced, right? When email came into the market, if companies were not adopting it, because they would say that I would need to set up an email server myself so that I could communicate with my clients or my customers who may or may not have an email server. So I may have to set up email server for them as well. It was not practical until a stage when companies like Hotmail, Yahoo Mail, Gmail started to offer email as a service, and email it was free in when it was launched for a limited size of your mailbox. But that feature or that approach or that strategy of providing a new technology as a service for a limited upfront capital investment was a very powerful strategy, and that was quite successful. So my vision for blockchain is along the similar lines. So we want to make blockchain accessible and affordable to any business who wants to leverage the power of blockchain. And for doing that, we are exploring, we are thinking of ways in which we can achieve that. I mean, is it possible that we can follow a similar strategy that email service providers used in the late 90s? And can we provide some hope for small to medium-sized businesses who want to embrace blockchain technology to make or to take their business to that next level of engagement with their consumers? And the answer to that question is yes, we can. And that's when we launched this platform called as Anything to Blockchain. And the idea behind Anything to Blockchain, or as we call it, A to B, is very simple. What we are trying to do here is we are simplifying the whole blockchain access path or approach, right? We have built a Web 2 platform or a Web 2 solution for companies to access blockchain, right? So let me explain what I mean by that. So at this stage, if any company or an organization wants to implement a blockchain solution, I said we used to spend 6 to 8 weeks to do a proof of concept. And then we will spend around 18 to 24 weeks to do a minimum viable product. So that was easily more than 6 months' time to get live into the market with a blockchain solution. With A to B, we are cutting that time as low as a day. So, and also we are cutting the time required, the cost required to get onto blockchain. So what we have done is we have built a Web 2 platform where companies can come and create a login, create an account using username and password. So we are not asking them to have a digital wallet or manage their public and private keys. We are just asking them, like how they normally do, log into the platform using the username and using their username or password, or logging using their social media accounts like Facebook or Gmail or or Apple ID. Right, so that is our core offering here. So this is the team behind A2B. So these are the people who work with me in the lab to build A2B platform, who have worked with me on the platform to build A2B. So with A2B, we are targeting two types of customers, right? One is an individual customer and one is a corporate customer. So what do I mean by an individual customer? Individual customer could be an example of an individual customer could be anyone who is like an artist, a musician who creates music, artist who kind of does paintings, or they do digital art, author who write stories, short stories, long stories, or any individual at a person level like you and me, who are creating some form of intellectual property, right? It's music, songs, videos, stories, photos. All these are individual intellectual properties that people create. So with A2B, these users can secure their intellectual property at least by posting their creation to A2B. So what I mean is, if I am an author, I have written a book, it's a script. I want to send that script to a number of publishers to publish, to see who will be willing to publish my book. What I will do, or what I would ideally do or should do, is I would come to A2B and upload my book or my story script to A2B first. By doing that, what I'm doing is I'm getting in return a confirmation that I own this piece of content. I have written this story, and this is saved on the blockchain on this day and at this time. Once that is done, so there is a immutable copy of your story on the blockchain that nobody can change. Once you have done that, you are free to then approach any of the publishing companies or publishing houses and tell them that this is the story that you have written, and you would like to publish it. So in a way, by putting it on a blockchain, you are safe that nobody can copy your work or claim that it is their work. This is also very useful for researchers, right? If you have written a paper, or if you have written any new creation, you have developed an algorithm or whatever, your creation, you can come to A2B and put that on the blockchain. And by doing that, you are at least saving that the information is there. Nobody else can then come and claim that they did it first. Okay, so that is the individual market. The second and a bigger market is a corporate market, which is businesses or companies that want to use blockchain technology for in their business to achieve some use case or for some objective, right? So we have to assess the corporate users. We have developed something which is called as templates, and I will talk about that in a minute. But before that, I want to outline or explain to you what problem does A2B solve. So the problem that A2B is solving for its customers, which is individual and corporate customers, is that it is removing the complexity with the use of blockchain technology, right? Second, it is reducing the cost and the associated uncertainty before making a decision. And third is time, because with A2B, you can get onto a blockchain like right now. And I will show you in the demo that I will do after this, is you can create a content that you want to put on blockchain, go to the A2B, create an account, and submit your transaction for submit your content to the blockchain using a blockchain transaction. Right. So the complexity refers to the blockchain and web technologies, which are, like I said earlier on, feel a bit complicated for a lot of users. So we simplify that with blockchain, with A2B. Secondly, the uncertainty in the development cost of a blockchain solution and the availability of workforce. So those two things can bump up the price or the cost of a blockchain solution. And third is time. The time to develop a complete blockchain solution can take quite some time. So we, with the technology that we have built in A2B, that interoperability, the interconnection between the user and the blockchain to the user and A2B to blockchain, that all is integrated and connected. Okay, so that was the problem. So in terms of the solution, so the solution that A2B offers is, it offers simplicity, right? So why is it simple? It is simple because A2B removes the Web3 complexities while maintaining the benefits of blockchain. Yeah, so it is a no-code platform. So you do not need to even know any coding to start using blockchain. It is that simple. The second bit is, it is affordable. It is a pay-as-you-go model that we have built, which means you do not need any capital investment to build or to maintain a blockchain. Yeah, that all is managed by the A2B platform. You just have to come and use the platform for your for any research that you, or for any work that you want to put onto the blockchain. And the next benefit is that it is accessible, right? We are making blockchain technology easy for anyone to use who wants to leverage the power of blockchain. So those are the three things that we are quite proud of when we have built the A2B solution, A2B platform. So what does A2B do? A2B technology lets you record anything to any blockchain in 3 simple steps. So here that word any is important, right? Because with A2B, you have the option to choose different blockchains, right? For example, if I want to store something on Ethereum blockchain, I have the option to choose Ethereum. If I want to use Polygon, I have that. If I want to use any other chain like Solana, Algorand, there are many different blockchains out there. So we are building connectors that can talk to these different blockchains. In the first release that we have built the connection for Polygon. And the reason why we started off with Polygon, was because the cost of transactions on a Polygon chain is quite low compared to putting the same transaction on a Ethereum blockchain. So we started off with that, but we do understand that companies may have a specific preference of which chain they want to use, because they may be already on that chain, or their customers or their suppliers may be using that chain. So we have in our plan to incorporate additional blockchains on A2B. So A2B helps you to record anything to blockchain in 3 simple steps. So you can see step 1 is to choose a blockchain and use a template to create a transaction. So that is step 1. So we can choose Polygon. I mean, at the moment it's only Polygon, but in the future you'll be able to use Polygon, Ethereum, or any number of chains. So that's step 1. Step 2 is to estimate the transaction fee and make a payment. So in this case, payment, we are also not asking you to pay using crypto. Yeah, not everyone owns crypto coins or crypto tokens. So you can make a payment directly using your credit card. So it is simple that way. And once that is done, you just sit back and relax because your transaction will be posted to the blockchain. You will get a confirmation once that is posted, and you can see that confirmation in the online dashboard. So with A2B, you don't need to worry about digital wallets, public or private keys, or even think about coding. So that is all not required because it is a simple, easy to use platform that we have built. So you as an individual or as a company can come to A2B, create an account, select an option where it is, say where it says create transaction, create a transaction, and pay for the transaction, and we then take care of the rest. So once you want, the moment you click pay, from there we start the Web3 element of A2B, which is we will use our digital wallet to sign your transaction and send it to the blockchain that you have selected. We will get a confirmation that yes, your transaction is added to the block, and we will display that in the online in the dashboard within A2B. So by doing that, you are able to get onto a blockchain any sensitive, any important information that you want to kind of timestamp, that I created it, it was done on this and this date, on this and this time, can be done with A2B. So we just need you to create an account using a username and password. You can pay for the transactions using a credit card. And we have built easy to use templates for companies if they want to start quickly to use a blockchain service. And I'll show you some examples. So templates is the core feature in A2B. So the reason why I say templates is the core feature in A2B is because templates kind of simplify the process of collecting different data points that are relevant for a specific organization. So imagine templates as a form, like a HTML form, right? From that you see on any website. And a form that has different questions. And what are these questions? These questions are questions that companies would want to collect information about and then share that information either with the department, government department, or with their customers or with their suppliers, depending upon who they are going to share that information with. So templates capture data points that companies want to store on the blockchain. Templates are editable, and this is the most important feature in A2B because every business is different, right? So they may have specific requirements that they want to capture using blockchain. So we make this, we initially design a basic template for different industries, but then we also give the option of editing these templates. So if a company says, okay, I don't want these 3 pieces of information, but instead I want to record these 5 things, they can do that easily using A2B. Templates are also industry specific, and we are making different types of templates for different industries. For example, we have wine industry, we have manufacturing, we have agriculture. Any industry that you think can use blockchain, we will make a template for them. And the way that we are currently working is we are identifying one user or one client who wants to start using A2B, and we are working together with them to build the first template. So by doing that, what we are able to achieve is we can get their inputs in designing a template. Say, for example, we got a winery company, they make wine. So we got them, we worked with them, we built a template for specifically for them. And because this kind of a template would be useful for other wineries as well, if any other winery wants to come and start using A2B, they have one ready to use template, which is editable. So they can go in and change any of the information that they want to. So like I said, the templates is like a form, and every time you fill the form, you have the option to, when you fill the form, you have the option to then save and push it to the blockchain. So after you make the payment, the transaction will go and will be recorded on the blockchain. So that makes you think, could blockchain be that simple? And when I give you the demo, you will realize that in fact, it is not a very complex technology. It just seems complex because the way to access it is not as easy or as common for a lot of people. But it is simple, and we are trying to make it even simpler with A2B. So what are some of the features of A2B? So we plan to have 100 plus templates to start with, and this could be one template for each industry that comes on board A2B. There is no coding that is required to use these templates. It will be a simple drag and drop kind of approach. There is no wallet, so you can just log in with your username and password. There are very low transaction fees, and there is no, basically the main important bit is there is no upfront investment to build a blockchain, because we have taken care of that. And that integration with your current system and with the A2B is seamlessly possible. So with templates is one way to do it. But as we started to work with different companies, one thing that we realized was these companies told us, and this is very important for us to get this valuable feedback, and this was that they would want their software that they're currently using to be able to connect to A2B, rather than using the template and refilling the same information. Many of the clients asked us, can you build us a connection or a bridge or something, that way our software can be interoperable with A2B. So now for selected users, we are actually even building an interoperable connection, interoperable platform, so that the software can easily interoperate with the A2B blockchain. And the way that we are going to do is to expose our APIs. So by exposing our APIs, companies can write specific code or logic to use our APIs to build that connection themselves. So we are in that process of building that as well. So I have some other use cases where we have seen companies come to us and start use A2B. So one of them is A2B for agriculture. And although yesterday I did mention about HiTrack and other few agriculture and supply chain based solutions, A2B can be equally used for that, and it could be much faster for any company to now come to A2B and to begin using blockchain quickly. So in terms of agriculture, what we can achieve traceability using blockchain. We can ensure the food quality of your food is ensured properly. All the compliances are in place. All that information can be recorded on A2B. We can also use it to show that the farmers are using sustainable methods to grow or to farm, because that is becoming very important for the overall climate change problem that we are facing. And also there has been a shift in the users' perception or users' requirement, where the consumers are now saying that we want to know how you have grown this. Have you used sustainable methods that are good for the environment. So that kind of push is coming from the end user or a consumer. And with a blockchain and A2B, you can easily prove your farming methods in a very transparent way. Finally, if you are a farm that grows organic produce, you can also use A2B to show how you have followed all the recommended farming techniques for growing organic produce or organic food. Yeah, so that is an example of how A2B can be used by the agriculture sector. So with A2B's industry-specific templates for agriculture, it's easy to store such provenance information, such provenance data in a on a blockchain as it is happening. So anyone along the supply chain can contribute parts of this whole thing, right? If you imagine the agriculture supply chain starting at the farm and ending at the customer, there are a lot of stakeholders or suppliers in between that supply chain. So with A2B, we can even configure it in a way that every supplier within the supply chain can add to the blockchain and help build that story, whether it is for provenance, whether it is for organic growth, or whether it is for sustainable farming techniques. So everyone in that chain is accountable to provide some information to the blockchain during that whole process from farm to the consumer. A2B can also be used for manufacturing. So you can see these days consumers are demanding transparency around how the products are manufactured. They're looking for ethical products, which means products that have been built in a way that is not exploiting people, or it's not exploiting the suppliers, right? So in many countries, there is the issue with child labor. So that challenges like that can be resolved by companies by providing all information in a transparent and accessible way to its consumers. So A2B has a manufacturing industry template, which is again fully customizable, that companies can use and start putting this information. And again, like I said, the entire supply chain, starting from the raw material suppliers and all the way till the end consumer. Even for apparel industry or clothing industry, it also suffers from a lot of challenges, such as counterfeit products or counterfeit clothes, especially if the clothes brand is it's a very popular and a well-known brand. There is a lot of fake products that enter into the supply chain. So blockchain can be used for managing that aspect of the supply chain as well, to prevent counterfeit products entering into the supply chain. Similarly, it is also very useful to prove the sustainability of garment manufacturing or clothing manufacturing. If you are, I'm not sure if you know, but when you're wearing a cotton clothes made from cotton, there is a lot of water that is consumed when manufacturing a cotton fabric. So there's a lot of things like that where providing the right information to the end consumer is going to help companies be better and more transparent with their consumers. A2B will also allow individual artists to permanently record their designs on a blockchain before sharing it online. There had been cases where, I will not name the companies, but these companies actually imitated the designs that were made by Australian designers and came up with a with clothes with those designs on, and the artist or the creator community was not very happy about this, about how these large corporations kind of used the copyright loopholes and basically used their designs without paying any royalty to them. So other than that, other than the 3 use cases that I showed you here, there are a number of use cases where blockchain can be used, and A2B is there to support these different use cases and getting these companies or these these product and manufacturing companies on board a blockchain. You can see energy is here, media and entertainment, government, health is another very important use case, education, retail, transport, agriculture, mining. So the list is quite exhaustive in terms of where blockchain can be used. What has to be the next step is to figure out how can companies now appreciate the value of blockchain and start coming on board blockchain platform using A2B, because it is very easy and affordable, and start connecting with their customers using this fabulous new technology. So we are just getting started with A2B. So we have started this 6 months ago. Our proof of concept is ready. Our MVP would be ready in the next quarter. And we will do an official beta release in the Q2 of 2023. So if any of you are kind of keen to work on a real live project in the blockchain space, then I would suggest you get in touch with me for this. Okay, so I will now show you a few screenshots of the platform, and then we will actually go and have a look at the actual platform software as well. So this is the login screen. This is the profile page where you can see we are only asking your name, email, mobile, and password. We're not looking for asking you to create a digital wallet. So you don't need to manage your public keys and private keys. It is all it is fairly simple using this with A2B. With sign up, we have 2 different types of signups. One is for individual and one is for a company or a corporate. So depending upon what type of a user you are, you can decide to go either way. Creating a transaction is very simple. So here you can see we have given 2 options: public chain or a private chain. You can choose one of them. You can enter the transaction title, what transaction you want to add. You can then give a short description so that you remember what this transaction was about. Then there is an option to select a blockchain from this list. At the moment, there is only Polygon. We also have created the option to share the blockchain or the transaction with another individual or to a group. So we have the option to create groups, and we can share it to the group, or you can share it individually by adding their email. You can also attach files to the transaction. So the file attach option is here. And once you attach file and then works out how much is the transaction fee that would be required. Here it is showing $78, but it's not that expensive. When we do a real demo, I will show you that it is just over $1. We also have the option to add your credit cards, and with these credit cards, you're able to pay for all the transactions that you want to put on the blockchain of your choice using A2B. This is a dashboard of the transactions. So whatever transactions you initiate using A2B, they will be visible on the dashboard. So you don't have to actually go to the blockchain explorer page for any chain. All that information is easily visible and accessible from here. Plus, we have given a link if you want to go and verify whether that transaction was is really on the blockchain or not. The link is there, which you can use to go and check. On the bottom side, the bottom here, you can see different templates that we have created for this. So if you are in the real estate industry, you could use this template. And if you want to change it, again, these templates are all editable. Milk industry, apparel, fabric industry, plus there is an option to search as well on the top. This also shows the more detailed list. So here you can see the transactions are shown here. If you want to see a complete list, you can see through this navigation bar on the left, where it shows all the transactions that you have completed. Here you can see the supported blockchains on A2B. So Polygon is highlighted at the moment because that is what we have done. But then we will get other chains on board slowly. Okay, so that was the explanation for the background about A2B. And I'll do a demo, but what I will do is I will finish the remaining slides where I want to talk a bit about blockchain interoperability and give you an example of some of the interoperability platforms that you can later study, but this will be a very high level non-technical explanation about blockchain interoperability. And then I will do the demo to show you how A2B works. So for blockchain interoperability, I want to start off with a definition of a few definitions, in fact, to kind of explain you or give you a background of when we're talking about interoperability, what we are actually referring to and why is it important. Okay, so this definition of interoperability here, you can see it says that the semantic dependence between distinct ledgers. So when we are talking about distinct ledgers, it means two different chains or blockchains to transfer or exchange data or value. So what are we transferring or exchanging? Either we are exchanging data or we are exchanging value with assurances of validity, right? So what this is trying to say here is when we have two different blockchains and we want to share some information from this blockchain to this blockchain, that is basically how we define an interoperability or interoperable blockchains. So when we are transferring some information from this blockchain to this blockchain, that transfer could be about data or it could be about value. So data is any kind of data, and value could be a value that is associated to that data. For example, if it is Bitcoin, then you're transferring the value in form of Bitcoins. Interoperability is also referred to as cross communication because we are having a communication between two different blockchains. So this definition by Pillai and Biswas, 2019, it says that cross communication is not intended to make direct state changes to another blockchain system. So we are not going to change the state of another blockchain system, but instead cross communication should trigger some set of functionalities on the other system. So let's imagine this is the blockchain A, this is blockchain B. Blockchain A wants to trigger a functionality on blockchain B. So trigger some set of functionalities on the other system that is expected to operate within its own network. And an example, so you may think, what is the functionality, right? And I will also show you in A2B how we have used this concept to compute the gas and the transaction fee for A2B transactions. So the cross functionality could be, this is blockchain A, right? This is blockchain B. Blockchain B could be a storage or an oracle, which is kind of has a collection of data. Let's imagine this chain is a finance chain, and it is keeping a record of the exchange rate of currencies, right? How much is the exchange rate between Australian dollars to Indian rupees, or US dollars to Australian dollars, or euro to AUD, and so on. So, and this blockchain on the left side here, that may be wanting the current exchange rate for doing some computation here, right, on their smart contract. So as part of that, so this chain may have to go to this chain to just use one functionality, which is tell me the exchange rate of Australian dollars to Indian rupees. You go get that functionality, execute that functionality, get the result, and you use that result on your primary chain. So that's why it is said that a cross-chain communication is not going to change the state of this blockchain. So this blockchain is it is how it is, but they have another blockchain can come to this blockchain, do some calculations, and come back and use that results. There's another definition of blockchain interoperability provided by NIST, or National Institutes of Standards and Technologies, I think. And here they say, they define interoperability as a composition of distinguishable blockchain systems, each representing a unique distributed data ledger. So distributed data ledger means a blockchain, where atomic transaction execution, so this is important, atomic transaction, may span multiple heterogeneous blockchain systems. So it could be one blockchain, another blockchain, and these are different types of blockchains. And where data recorded in one blockchain are reachable, verifiable, and referable by another, possibly a foreign transaction, in a semantically compatible manner. So in simple words, if this blockchain is going to use information from any other heterogeneous blockchain, this blockchain should be able to reach, get that information, should be able to verify, and later should be able to refer as well, that we got this information from this blockchain for this purpose. So that is another way of defining a blockchain, defining the interoperability. So what are some of the key features? So cross-chain feature, a cross-chain technology or cross-blockchain transfer technology works on the principle of atomicity. So what does atomicity mean? Atomicity means that in case of databases, right, we have a concept of atomicity as well. And what that, in the context of databases, what do we mean by that? We mean that at any specific point of time, only one transaction would be able to change the content of a cell in a table. Yeah. So you cannot have one transaction changing, say if you run a SQL query, that cannot go and change the content of a database cell in a table until it is unfrozen or unfrozen, right? So whenever you send a transaction to a database, it is an atomic transaction, because there can be only one thing that can change the information in the database at one time. So if two transactions come to change the same data, there will be a conflict, only because this cell will be locked for a time when one first transaction is executing. So in the case of blockchain as well, we have the same concept. So if blockchain atomicity works in form of, if I have to send an asset which is on blockchain A to blockchain B, that asset transfer, how will it happen, right? Because if I send one asset from here to here, there will be two copies, right? So if it is one Bitcoin I send from here to here, they'll become 2 Bitcoins, but that is not right? So that transaction has to be atomic, which means if I'm sending something from here, is going here, it should be either burned or locked on this chain. And a equivalent replica is created on the other chain. So we are still atomic. This also enables proper consistency between several interconnected blockchains. So in reality, it is not just going to be two blockchains, right, that they want to talk to each other. There could be multiple blockchains when we are envisioning blockchain interoperability. It also enables the distribution of networks across various platforms. And this is again going back to the same example of currency exchange rate. So there may be one blockchain network that's only there to tell you to do the payment processing or to do exchange rate calculations, and then they provide that information. The next is the importance of interoperability. Interoperability enables users to share data and trade tokens without any intermediary across multiple blockchains for free, more freely. So not for free, more freely. And what that means is, at the moment, if you have to change exchange tokens, so if you have to change Ethereum to, say, Bitcoin, you have to go to a centralized exchange, right? So there are some decentralized exchanges as well, but the most popular ones like Binance is a centralized exchange where you can go and change the tokens, right? But if there would have been this interoperable blockchain, and I have Bitcoin on the Bitcoin blockchain, but I want to get Ethereum instead, there should be a way that I can transfer Bitcoin from here to, there should be a way for me to transfer Bitcoin and get Ethereum instead of, in return for that. So interoperable blockchains in the future will be able to achieve that level of sophistication. It also helps blockchain to improve their efficiencies and security. And the reason why I say that is once the blockchain is a narrow focused blockchain, that it is only doing one bit of work, but very fast or very thoroughly or clearly, it becomes the efficiencies improve and security loopholes kind of reduce. It also helps in segmentation, because like I said, every blockchain is niche, achieving one specific purpose. Different blockchains can then interact to achieve the overall decentralized app development. The benefits of connecting two different blockchains is, firstly, there is higher scalability. What do I mean by scalability? Scalability refers to the standard term of scalability that is used in computer science, is you can increase the capacity of your network, right? So if there are two different chains, one could be a standard chain and one could be another chain where this information transaction has to happen. If this chain gets super loaded because there are too many transactions coming to this chain, there has to be some way to kind of direct or flow the work to another chain where you can finish the task and improve the performance of the chain. It also helps to enhance data flow, like I said, going data from one chain to the other, and also to helps in the transfer of tokens from one chain to the other without using a third-party exchange. And the overall benefit is that by implementing or by having interoperable blockchains, you kind of are discouraging monopolization by large companies, right? At the moment, if you see, there's the biggest and the most successful, blockchain exchange, token exchange or crypto exchange is Binance, right? A few months before, even last month, there was another exchange called FTX, but that collapsed. So now there is a very large monopolization possibility with just few centralized exchanges. But if you're able to build interoperable blockchain solutions, then this could become much level playing ground. Okay, so what are different types of interoperability? So broadly, I want to talk about two types of interoperability here. One is chain-based interoperability, and next is bridge-based interoperability. So what is the difference between that, a chain-based and a bridge-based? So chain-based interoperability refers to exchange of information between two similar types of blockchains, right? So I have Ethereum and I have Ethereum. Yeah. So those are the two types of blockchains, but these are two different, managed by two different companies, right? They want to communicate with each other. So that's why we call it as a homogeneous blockchain. So the type of blockchains are similar. Here, EVM means Ethereum virtual machine. So EVM compatible blockchain. So there are many different types of chains which are EVM compatible. So chain-based interoperability focuses on providing that form of interoperable connection. The next form is bridge-based interoperability, and this is where we these bridges are developed to build connection between two different types of blockchains, right? So it could be like here I can see, you can see a Hyperledger Fabric and Bitcoin. So one is a private blockchain, one is a public blockchain. So to connect these two types of heterogeneous blockchain platforms, we need to have a bridge-based interoperability solution. So in case of the first case, which is a chain-based interoperability, there are many different types of examples of services or companies that are providing chain-based interoperability. And you can see Loom Network, Rootstock, Liquid Network, Heredias, Bitfrost, AllChain, Cheapay, Commits. There are so many different companies providing different types of interoperability between the same homogeneous blockchain types. And similarly, for the other chains, the heterogeneous blockchains like Hyperledger Fabric and Bitcoin, we have to use something called as trusted relays or a blockchain engine. And these are different companies that are providing that form of interoperability between two different types of blockchains. Okay, so that is all I had to cover in the slides today to give you a background or information about how blockchain as a service can improve blockchain adoption, and how the same service can also be used for interoperability, right? To ensure that you can connect your client systems with your blockchains, make them communicate, and on the other hand, connect the blockchain by giving you multiple options of the different blockchains that you can use using A2P. Okay, so I will stop my screen share here and I will do a quick demo of the A2P platform so that you can see how easy it can be to implement or to start using a blockchain platform. Okay, I hope you can see this screen. So this is the dashboard for the A2B platform. And on the left side, here you can see the different functionalities that I presented during the in the lecture. So we have a dashboard, we have a profile page, we have payment, we have currency, reports, templates, transactions, and so on. So at the moment, I will show you how we can create a transaction, because that is the most important aspect of the blockchain of A2B. Right. So to create a transaction, we click on this. We click on create transaction button. It is now asking whether you want to create an individual transaction or a corporate transaction. So let's say we want to create an individual transaction. So here it is asking you to put the title of the transaction. So let's say A to B demonstration of how to post on a blockchain. So let me just use that as an example of title. This could be the content. Here you can say, I have written a story about I have written a story and I want to publish this as a book. And then I can say, I am attaching my story as a file. And here you can see there's the option to attach file. So I'll upload one sample file that I had created here. So that was an example of a Word document. And you can see here. And then here you can say just add a description. This is just to remind you what this transaction is about. Okay. So here you can see that the blockchain that we have selected is Polygon. So once I fill in this information, I have to click Get Estimate. And it is telling me the estimated gas fee is 1.0020002 Australian dollars. Do you want to continue? And I can say, okay, yes, I want to continue. And now it is going to the Polygon blockchain and it is adding information there. It then shows you that your transaction is submitted successfully. I'll click OK. I can go to the dashboard, click individual. And here you can see the transaction, it says it is completed. A2B demonstration on how to post a blockchain. So that was our title. When I click this, it gives me the link of where this transaction can be verified on the Polygon blockchain. So I click this. This is now showing the Polygon scan, which is like a Polygon network. You can see the transaction hash is here. It shows the status is success. This is the block. How many time ago was this done? From whom, to whom, and so on. All the other relevant information is here. So you can then say that this information was is there on blockchain. Yeah. So similarly, we can also create a say corporate transaction. I had one simple example here. So if this corporate company was a builder company, right? Building agency. Like a builder who builds the like houses or apartments. You can say building number 10. I'm adding all the information related to building number 10 here. I'll just copy the same thing for simplicity. And now here you can see when you're building a house, there are a lot of different paperwork that has to be completed. For example, do you have the building license? So you can either add the building license here. The building license number is 1, 2, 3, 4 or whatever, or you can also make add an attachment. Similarly, earthworks, you can say it was completed on 30th November 2022. When was the slab done? You can again add some information like that. White cars is an example. Like every laborer working on a site has to have this like an identity card, a proof of that you have the right skills. Occupational health and safety certificate, insurance copies. I'm just putting up the random data here, but when you're actually doing it, you will be putting all the complete correct information here. And then we can similarly get an estimate for running this. Here now you can see the estimate is showing is 1.00. So there's not much difference. It's roughly around $1 Australian to do this. Now it's putting all this information. Your transaction is submitted successfully. I click OK. You can go to the dashboard. Now, this transaction will not be on the individual dashboard. It will be on the corporate dashboard. And you can see here, this is the transaction. This is completed. Okay, so this is interesting here. This transaction has been included into block number this and will be reflected in a short while. So we can come back and at a later stage can check that this block will be, this chain transaction would be added onto the blockchain. And the reason why this happens sometimes is Polygon kind of collects a number of different blockchains, transactions, and puts them together. And once it reaches that minimum threshold, it will create the block. Let's see, it may be ready now. Okay, so now here you can see the transaction that we just now created is added to the blockchain. Okay, so that is all I had to present and share with you today. So if you have any questions, we can take some questions. We have a few minutes. And then we will take our regular break, and then we'll start the tutorial afterwards. Okay, so if you do not have any questions, Malay, maybe we can conclude the session and then meet in the start the tutorial sessions later. Okay, so if you have no questions now, let's conclude this session. And if you have any questions that come up during this break time, yeah, keep a note, and then we can discuss them during the tutorial session. Okay, thank you all very much.